here we go. So this one now, it is an equation. It says to solve it. All right, that's good. Now I'm going to complete the square on this one. And if you tried to factor out 31 here and say, or even if you tried to add 83, 31 plus 83 is 114. There's no two factors of 114 that will add up to negative 16. So that's no good. So here's what I'm going to do. I want first to get the x's on their own side of the equal sign, meaning not just the x squared, but also the negative 16x. This also tells us that I don't want, right now, the 31 on the same side. Okay, now if I'm solving an equation, I'm going to put my constants on the other side of the equal sign. And there's a reason for that.
So we're not going to do it.
So, yeah, the 31 there, I'm going to zero it out by taking 31 away, so minus 31 from both sides. That does zero that out. That's very nice. But negative 83 minus 31 is negative 114. Now I am ready to complete the square. And again, we're looking at this it's binomial, but I'm going to force it to become a trinomial. Okay, so what value am I going to add to that? Well, I'm going to take the middle coefficient, and I would actually call that middle coefficient negative 16. Remember, we're going to divide it by 2, and then that value we're going to square. So then that would be, thank you, negative 16 divided by 2 is not negative 4. It's, or whatever the crap I put. It's negative 8. And then negative 8 to the power of 2, thank you, is 64. Now over here in the equation, remember, whatever you do to one side, you have to do to the other side. So where I'm completing that square by adding 64 here, I need to make sure I do it to the other side as well. Okay, so now, because it's an equation, whatever I do to one side, I got to do to the other side. It's not an expression where I'm trying to zero out this 64 on the same side, where if it were an expression. If I add 64 here, I can just simply add 64 there, and I can call that good. Now this trinomial, because we used the perfect square process here, is going to be a perfect, it's perfect square trinomial. It is a perfect square trinomial. So the 64, what two factors of 64 add up to negative 16? Yeah, it's the negative 8. Well, didn't we see that before? Yeah, we did. Remember the negative 8 over here? It's the same one. Now, instead of writing this as two binomials, I'm still going to write it as two binomials, but as a square, because that's what it is. So it'd be x minus 8, that to the power of 2. Maybe I shouldn't have written that so big. But then I've got the negative 114 plus 60, which is, sorry, plus 64. Yeah, negative 50. So this takes us back a couple slides, where now I'm going to square root both sides because it's a square, right? So if I square root both sides, and it doesn't matter now that that's a negative 50 because we have complex numbers. But now I just end up with, remember, I'm square rooting both sides, so I'm going to split this up into two equations. So I got x minus 8. It could be the positive square root. Well, I'm just going to put I and then 50 right here. So I skipped a little bit of a step there. But if x minus 8, if we could get that to equal the negative I square root of 50, that's fine too. So to finish this off, principle of equality for both, and it's the same thing for both. I'm just going to add 8 to both sides. I would consider these not like terms that I can combine. So I end up with x. It could be 8 and then a positive I square root of 50. Or x, it could be, because we zeroed these out, 8 minus I times the square root of 50. Put an or statement there. Both of these are good. Yeah, I forgot to mention, because I forgot here, always simplify your roots if you can, and the square root of 50 can be. Now I'm just recommending you just plug that into the calculator and be done with it. All right, so you'd have 8 plus, it'd be 5. I root 25, that'd be 2. And then also 8 minus 5I root 2. Okay, because 50, I'll do this by hand, but that'd be 25 times 2. And the square root of 25 is where that 5 comes from. But it would work for both of these. Again, yeah, I hope it's not, but again, to simplify this, especially if you're looking to save time like I'm trying to do right here, just put this in the calculator, square root of 50.